Okay, can you hear now? Okay, perfect. I think something must have perfect. Right, that was a bit odd. Right, that must have happened because I started recording and the mic stopped working for some reason. I have no idea. So what Matthew said, to disprove the, well, I'm just going to repeat what I said before I realised you couldn't hear me. To disprove a statement for any proof, you just need to find one example of it not being true. This trying a number will literally get you a method mark. It's not the answer, but it's a method. So Matthew tried a number, saw it wasn't prime. I'm guessing he tried n equals 3 because I was asking him what number he tried. So let's try 3 squared minus 3 plus 3. We get 9, not prime. So you've disproved it. That's literally it. Okay, so that should make sense. And so generally, some proof questions can be bankers, and we are missing them out because we're not sure what to do. So prove the sum of two consecutive odd numbers is a multiple of 4. So just because I don't want us to lack time, so an odd number can be 2n plus 1. It's consecutive odd numbers, so it's going to be 2n plus 3 is the next consecutive odd number. And we expand that, and we're going to get 4n squared plus 6n plus 2n plus 3, but that is not the sum, so I've done the product here. But if you get a product, I've seen a question like this actually. They will say this is a product, and they might ask one less than a multiple of 4. If this is a different question, so do read the question carefully. And actually, if you factorize this one, if this was a question, prove that the product of two odd numbers, so I'll change the question, is 1 less than a multiple of 4. You can see that's 4n squared plus 8n plus 3. Now we can factorize this 4 out to get n squared plus 8 plus 3. And then you can see this is 1 less than a multiple of 4 because that's a multiple of 4. And 3 is 1 less. That's if they're asking for the product. This is sum, so it's add, so this is even easier. That's going to be 4n plus 4, and factorize that out, must be a multiple of 4. Okay, so that should make sense. Question 4, so we need to prove that this does not equal this. What do we do here? And then you're not sure, you should just do one thing to get your method mark. So what do we think, people? Could expand it, and in a way, so if that's our identities question, that would be kind of correct, but we should know that if we expand the left-hand side, equals x squared plus 2xy plus y squared. So you can see it's different, but arguably you could do that, but also you just need to find a counter proof, which is called counter proof, don't remember that, and choose a value for x, so say x equals 1 and y equals 3, see what happens. So you get in this side, left hand side, equals 1 plus 3 squared, that's 4 squared equals 16. The right hand side will be 1 squared plus 3 squared equals 10. And so left hand side does not equal right hand side, and that will be enough. And you can say this as well. I would accept that as well. So well done, Christina. Does not equal x squared plus y squared. Perfect. So question 5a, and this has come up in one of your mocks, something similar, I remember. Prove that n squared plus n plus 11 is prime for all integers between 1 and 5. So this should just be a banker mark. What do we know? You should just get this 3 out of 3 every time. They put these questions here just to check your understanding of proofs. Yeah, put a number in, but not only that, Christina, you put all the numbers in between so that you prove it. Because if you just do one, that's just proving one of them, but you need to prove, because this is a range and it's not many options, you just put in, just show you're working all those numbers between 1 and 5, So between 1 and 5, I believe would include you, and this is called proof by exhaustion. It's a limited range. So essentially you just let n equals 1, work that out, n equals 2, n equals 3, n equals 4, n equals 5, show that they're all prime, and that's called proof by exhaustion, because you've covered every angle. Well done. Now, if you now for this, prove that n squared plus n plus 11 is not prime for all values of n. Literally, just try a value of n. Try a value of n when it's not prime, and there will be one. And once you've just done that, you've proved that, and that should make sense. So, question 6, that's a free marker. And I can imagine some of you will not have got this right if this question came out. It says prove by exhaustion that the sum of two even positive integers less than 10 is also even. To prove by exhaustion, because I've just shown you what proof by exhaustion is here, you must you'll sort of understand what you need to do here. Literally, it seems really easy, but it's only if you know what it's asking you to do. So just show 2 plus 4, that's the sum of two even positive integers, equals 6, that's even, so it's even. 2 plus 6 equals 8 is even. Obviously you have to use 2 plus 2 equals even. And literally to get 3 marks out of 3 for all this is just do all the combinations. So 2 plus 8 equals 10 even. And hopefully that makes sense, but just show all the examples. Are we happy with that? Yeah, thank you. Now you can see, so there's so many proof questions you can actually hit the marks, and even my class, we don't always get the marks for them, all the full marks. Thank you, Mia. Okay, I'm going to move on to this question here. Now we've done 12 in the past. Question 3. You should be good at solving trig equations using the trig diagram, the cast diagram as well for solutions. But if you look here, we can't start to solve this because we've got a cos term and a sine squared x term. So what do we do here to start us off? Yep, perfect. We change this because we know cos squared x plus sine squared x equals 1, so we change that to 6 1 minus cos squared x. Now remember, this only works for a squared x term, so don't make that mistake. Equals 8 minus 7 cos x. We expand all this out. 6 minus 6 cos squared x equals this. We bring it all on one side. We want to have a positive cos squared x, so we're going to bring this over to get 6 cos squared x. I'm going to minus a 6 minus 7 cos x, and that is going to be plus 2 equals 0. We factorize, and then we should be good at finding solutions from here. Generally, I noticed everyone can find the values once they can factorize this, but people just get stuck on this stage, and that's when they lose a mark. So that is correct, Christina. Well done. So we should be happy with that, hopefully. I'm not going to get you to do that because of time, because once you factorize this, you should be able to do it. And if you do need to factorize it, it's probably going to be a 2 and a 1 somewhere. That's a 1 plus, we're going to get a 3x, 4. Yeah, that's going to be cos, yeah, it's going to be 2 cos x minus 1 and 3 cos x, 6x squared minus 4 minus 3 plus, yeah, equals 0. So hopefully we know that we're just solving this, right? And we solved that, but we should be good at that stage. So I'm going to leave that out. Are we happy to move on from here? Because I think you can do it from this stage. But once you undo all this, you're going to get your 6 out of 6 marks at least, or 5 out of 6. Or do you want to just give it a go and see if you get the answers? I'll let you decide. So what we're going to do, see if you can find all the answers to that, or just move on to 12. Okay, off you go. Find the answers then, and whilst you do that, I'll get the answers myself. Oh, all right. Eric's has moved. Well, we're going to find the answers. It's not going to take you long. Make sure you can do that. Right, but Eric, you can go and give 12 a go and see if you can get that right. So you've got two options. Just get the answer to 3, or just see if you can get 12 right. Start thinking about 12. The next question. And I believe those will be the answers for that. And so, Eric, any ideas how to do 12? 12 can be a little tricky. So you expand all of this. So you're going to get 10 minus 10 cos squared x minus 7 cos theta plus 2 all over 3 plus 2 cos theta. You're not sure, you either factorize or divide the top. Yes, this becomes difficult if you're not sure what to do. But if you simplify this top, let's see if I've got space here. We're going to get 10 plus 2. We're going to get minus 10 cos squared x minus 7 cos x plus 12 all over this 3 plus 2 cos theta. Now, because we need to show this, it's 4 marks. Using identity is probably worth 1. And the clue here is this is in general, most of the time, going to be a factor up here. So essentially, if we factorize this, we're going to have, I'm going to say that's going to be here. Now we're going to have, the clue is we've got to sort of make this here, but 3 plus 2 cos theta. Now, got to think, we've still got to make the 10 cos squared. So I'm going to say that's got to be 5 cos theta. Now I'm going to jump a slight step here, but that's got to be 10, but we know it's going to be a minus value and we get a plus 12. Okay. And I'm going to put a minus 4 here. Now, because it's going to be a minus 10 cos squared x, we're going to take the minus sign outside. Another way is to just factorize this. If you factorize this first, let me do an arrow here so it makes a bit more sense. If we factorize this first, we're actually going to get this. Because if I jump to that, it might not make sense to you. That's a 3. That's going to be 5 cos theta minus 4. That factorized is this here. This term here does not look like what we have here. But can you see if we've got the minus signs in both, we can take the minus sign on the outside. Now, if we put the minus sign on the outside, of this, you will see minus times a minus here will change that to a plus 3, and minus times a minus will change that to a plus 2 cos theta. And that's how I jump from this bit. So essentially I'm jumping from here to this section here. And now this will cancel. So we get left with minus 5 cos theta minus 4. Now if we put the minus and then if we expand that out, you can see that becomes 4 minus 5 cos theta, what they've asked you to show. Excuse me if I mixed up x and theta. And that is how to get your full marks. But you can see that is a little bit tricky, and that will catch quite a few people out. So Christina, but you had the right idea to earn some effort marks, so well done. Eric, did you get that? Well, I'll give you a minute to ask any questions. But if you have no questions, think about how we can do part B now. Change the purple for B. Okay, well done, Eric. That is actually really good thinking if you got that. But you can see that it can be a little tricky, but it's 4 marker, so well done, Eric. So Eric, how would we do part B, do you think? How would we start B? Because part B, once you've got the start of it, it becomes very straightforward. Work out for cos x. No, not quite. I don't know what you mean by that. Because really, the clue is this is exactly the same as this. So we can't work out anything yet because we've got cos and sine terms in there, right? Change the sign. Change the sign, yeah, but remember it's 3 marks, so you could do that. But what I want to say here is we don't want to mess around with this. But the key that what you've got to notice is this side is the same as this, right? So once we work out that, we know 4 minus 5 cos theta equals 4 plus 3 sine x. Right, we can minus 4 from both sides, so that we get left with minus 5 cos theta equals 3 sine x. Now we know sine x over cos x equals tan x. So we divide both sides by cos x. We can get there. And then you can solve it. Oh, keep these terms the same. So we get minus 5 equals 3 sine theta over cos theta, which we know that becomes tan theta. So essentially we get minus 5 over 3 equals tan theta, and then we solve like normal and we can get the marks. But without doing that, it'll be very challenging to unlock that question. And then you should all be able to solve from there. So that's that. But I want you to take a note of that skill, because using identities, trig identities, is going to help you answer those more challenging solving trig questions. Because I believe that question, if it appeared, would throw a few of you off. William, are you trying to say something? You flashed up. But your mic is off. Or Christina, does that mean you're typing? I'm not sure. So do make a note and then let me know when I can move on for some more questions. Yeah, don't worry about what you have on your comments. When I edit this, I chop off your comments and chop off a lot of the gaps in speaking, so that when you come back to look at this, if you need to, there's less waiting around. So I do spend, when I have time, about 20 minutes to half an hour cutting out all the silent parts, so you just get the examples and then upload it. Right, so let me know when we can move on from there, or if you want me to explain anything again. You're good, Nia? Okay, perfect. So question 4, it's a linear modelling question, and for some reason students will find modelling a bit challenging, but this is question 4, so it should be more straightforward than you realise. So what do you think we do for this? If it's a linear model, we know what do linear graphs look like. Should give you like a minute to read it, but I'm just going to start. Y equals mx plus c, correct? But we don't have things in, there's no y or x, but we twist the terms around. I'm just going to give you 30 seconds to read that and process it, and I'm just going to go through the question because I'm conscious of time. But when I show you it, you think, oh, that's not too bad. I can actually do that. Linear model, y equals mx plus c. What do we actually have? We've got h against t. So we can just change that to h equals mt plus c. T is years. So we substitute this in, and we've got the height in meters to help us find c. So equation 1. At 3 years, height is 2.35, so we get 2.35 equals t is 3 for that, so 3m plus c. And the second equation, after 6 years, the height is 3.28, so that's equals 6m, that's 6 years, plus c. Now, if we do 2 minus 1, equation 2 minus 1, that should leave us with 0.93 equals 3m, or m3, 3m, because the c's will cancel. So then that helps us find the gradient. So m equals 0.31. And it says find an equation linking h with t. Well, once we've got m, can we find c? Yeah, we just substitute that into any formula. So let's just do 2.35 equals 3 times 0.31. This is equation 1 I'm subbing into. Plus c. And you can sub it into either one, it will work. Work out what c equals. The c equals 1.42. So this is all your method marks earned, and your last answer mark will just be substituting your answers into here. You get h equals 0.31 t plus 1.42. Now part B, it says the height of the tree was approximately 140 centimeters when it was planted. Explain whether or not this fact supports the use of the linear model in part A. What do we do? How do we show that for a nice 2 marks? Compare with y-intercept. Yep, you're on the right track there. Well done. We can just substitute it with our model. Now, because it says approximately, I would have preferred if they said 141 than 140. So the height of the tree, we get 140. Just use this formula. We get 140 equals 0 times, because time is 0, 0 times 0.31 plus 1.42, but it's in centimeters. So if you think about this units, that's 142 here. That's 1.4. So actually I should write 1.4 here. And that equals 1.42. So we get, I mean, that is very close, right? So it does support it. That's approximate symbol. So yes, this supports the model. Yeah, William, yeah, make t equals 0, because that's when the plant is, the tree is planted. And when t equals 0, well, our model has the y-intercept as 1.42 linked to what Mia and Ella were saying. And you can see our model, it does say approximately, so that tree could be 141. And you can see these values are very close, so the model is pretty accurate. And I hope that bit makes sense. But unless this is shown, that can be quite confusing to answer, if that makes sense. Have sub 2 into 1. No, I didn't sub 2 into 1. I did 2 minus 1. So let me do it right this way. 3.28 equals 6m plus c. And 2.35 equals 3m plus c. So the whole point of doing this model is to find m and the y-intercept c from the making this model. So if we minus if we minus all of this, we get 0.93 equals 3m. And from that, that's how we found our m. Once we find our m, we can sub that into any one of these and find out c. All right, perfect. I think we're okay with that, but I think that's important to show because you can get the marks for this if it comes up. But because you don't get much practice doing it, you could be thrown off, and that's 5 marks, which is worth half a grade, I would say, right? Okay, moving on. Right. Make it greater than 0, Christina. Well, yeah, you do normally have to factorize or solve. You could use your quadratic inequalities if you remember them. It really depends on the question though, Christina. So let's see what happens. So dy dx, we need to write that. Yeah, we know that's 6x. I always write this as 3x squared plus 24x to the minus 1 plus 2. It makes it easier for me to differentiate. And then so we get minus 24x to the minus 2. That's perfect. So when the curve is increasing, you set it to 0, because imagine if this was a curve. I mean, it's some kind of quadratic, right? The curve is decreasing when the gradient is negative, right? And you can see, well, it must be increasing if gradient is positive. So we need to find dy dx is greater than 0 for this. So we write 6x minus 24x minus 2 is greater than 0. Now, I'm going to multiply both sides by x squared to cancel out this x minus 2. So we get 6x cubed minus 24 is greater than 0. Let's divide out both sides by 6 to get x cubed. Or you can move the 24 over, then divide by 6. It's the same thing. Minus 4 greater than 0. Let's bring the 4 over now. And then we cubic root the 4, and that would be the answer. So in this question, you didn't need to factorize it, but you do make it greater than 0. Because you do need to show what values for x when the curve is increasing. So essentially any value past this stationary point, here this was a graph, will be when x is increasing based on that graph, because you know it's a quadratic. Does that make sense to you, Christina? Perfect. So that's just a key bit of extra teaching to recap that. And if they ask decreasing, the question was decreasing, you just say it less than 0, and exactly the same skill. and the decreasing will obviously give you the values on this side of the graph. So I've just drawn a graph there so you can visualize it and it helps with your understanding. All right, just because I'm conscious of time, I'm going to skip that one because integration, it's a question 3, so it's the start of the exam and you should be good at that integration type. So I want to move on to this one, modeling, because that tends to throw people off. So let's do this modeling one and one integration question, and then we'll be finished. I'm going to give you some time to read that question, process it, and see if we can answer some questions on it. So all types of modeling questions, if you use just a bit of thinking skills, you can always pick up some marks. So question A, 9A, for one straightforward mark, what can we do based on this model? What do we do? Sub 1 in for T. Are you sure it's 1 in for T though? Because what does T represent? You've almost got the right idea, but T, Christy, oh, you meant N. Okay, that's perfect. Now the key why people can make a mistake is it says in the N years after the start of mining. So that's 2019, it's 2020, so we don't use 2020, we just let N equals 1. That is perfect understanding of the model, Christina, so super star you are. So we just literally sub that in, N equals 1 squared, work out what that equals, use your calculators, 1,200 minus 3 times 19 squared, is that 361 is 19 squared? But anyway, yeah, use your calculators and we should get 117 tons. Do you put the units? That's important. Right. B, deduce the maximum amount total mass of tin to be mined. These questions are always familiar in that, or similar. Now, if you look at here, this is minus a value. So the maximum amount that can be mined is when this is the lowest value possible. Oh. Now this is the lowest value possible when it is 0. So that is when that equals 0 or N equals 20, right? It's not asking that, but that's when N equals 20, because that will make it 0. So literally you can just state 1,200 tons. Right, so C says calculate the mass of tin that will be mined in 2023. So you should be able to get 1 mark out of this, but you can miss out on the second. What do we think? What do we think? Put in 4 for N. Yeah, that's going to get you 1 mark. Put in 4 for N. That will get you 1 mark out of the 2. So we get. So when we have T equals 4, that's for January 2023. So we're going to get 1,200 minus 3 times 4 minus 20 squared. And that's going to equal 432 tons. That will get you 1 mark. That's good. So we can get 1 mark. It doesn't actually get you the second mark. Now, to understand the context, imagine there's a mine. Where's my pen? There's a mine, and it could be in a cave or it could be in the ground. And we know 20 years is the max. Well, we know 1,200 tons is the maximum that could be mined. Tons. So all that means is there's 1,200 tons of tin in the mine, or of tin that we could access. Tin in the mine. Right? So when we have put T into as in 1 year, 117 tons is mined. In 1 year. Now I believe This question is asking how much tin will be mined in 2023. Can you see this answer here includes your first year and whatever your second year is? Because that's after, this means after 4 years actually. Yeah, because we started 2019. After 4 years, 432 tons of mine of tin is taken out. That's Jan 23. 4 years of tin. After 4 years, 432 tons is taken out of tin. But it's not what is mined in 2023. Yeah, that's how much is taken out from 2020, 21, 22, and 23. So we're just missing one step here because it's asking how much was mined in 2023. Yeah, so only for that year, not including year 3, year 2, year 1. This includes. Yeah, good. You could. So, yeah, you could work out. It should work. Years 2 and 3, then minus it, see what's left over. But if you think about it, if we do Jan 2024, which will be 5 years, we sub that in. So Jan 2024, we get 1,200 minus 3 times 5 minus 20 squared. We work that out, and that gives you 525 tons. So if you do 525 minus the 432, we get left with 93 tons. And that will be the answer. Now that should make sense now. So yes, Christina, you had the right idea. Well done, you. D, state, given reasons, the limitations on the value of m. Well, I gave you the clue here, right? M equals 20, because after 20 years, you're going to get less than the maximum value of the tin, because this will become a value that we can subtract from this, and that makes no sense because from this model there's only 1,200 tons of tin. So after 20 years, the amount will decrease, which doesn't make sense or not possible. The amount will decrease. So this is the key bit here. It will be an inequality. So m has to be equal to or less than 20. We know it can equal 20, but that will be the limitation of that model. Are we happy with that? And we'll move on to one last integration exam question, just because that involves some skills, and that will call it a day. But you can see there, modeling's not too bad. You can earn some marks. You just have to think about it and understand it. But I can see you don't do it often, don't get enough practice, so that's what can be challenging. Right, can I move on? Unless you have questions. And yeah, apologies if I'm talking very fast, just conscious of time. I can slow down if required. Big 7 marks. Now, obviously, to integrate this and to find r, this point is k. How can we find this point k? Because without finding the point k, we can't really do the question, can we? Well done, Matthew. That is the key. Find the points where the gradient is 0, because you're going to get a gradient of 0 here and here, and then we can use the gradient function for that. So I'm going to write this up here. dy dx equals 6x squared minus 34x plus 40, and we need to set it to 0, and we'll get these 2 points. So 6x squared minus 34x plus 40 equals 0. These numbers are a bit big, so I'll try to simplify that. These are all even numbers, so we can divide all this by 2. So we should be able to factorize that. Because it's a 3, I know one term's going to be 3x and another term's going to be x. And factorize that whatever way you will. We're going to have a minus 17 and a plus 20, so we're going to have a minus number. We're going to get a minus 4 and a minus 5. Minus 4. Now, if I have minus 4 here and minus 5 here, that gives us the minus 12x, and that gives us the minus 5x. That's minus 17x, and that is correct. And you can see we get it at 0 when x equals 5 over 3 and x equals 4. Well, obviously this point is 5 over 3 and that point, so k equals 4. So we've unlocked that, and we'll just write somewhere k equals 4, make it clear that we know what we're doing. But normally this will give you the mark because you've indicated that's 4 there anyway. But I would write it just so the examiner spots that. Now we show that area of R is 256 over 3. Well, that's just integrating it. Do integrate it though. So what you're doing is between 4 and 0. I believe if you do this on your calculator, you type in what y equals, not your integrated function, to get the answer. Okay? That should make sense. You type in this, because I think if you type in what the actual integration, it would integrate that, whatever you put in, and do that answer with that. But do have a check and double check that. But you do need to show this. It says solutions based entirely on graphical or numerical methods are not acceptable. So do integrate it. How I do this is I know the power goes up by 1, so that's got to be a 4. How we're going to get the 2 when we multiply that out, it's got to be a half there. Minus x cubed that time, so that's got to be 17 over 3. So when we differentiate it back, how we're going to get here, and we know that is, oh, I've missed an x out here on the question, right, and then that's going to be x squared. How we're going to get the 40, 2 times 20. That's what we write down for our method marks. Show yourself subbing that in. So you can use your calculator to check your answer is correct. That's all you use your calculator for. Because I think if you just put in the, well, it does say show that anyway. So this is different. You have to do it because you're showing that. If you just whack in the answer, you maybe get 1 answer mark out of the 4 methods available. Just make sure you put everything in correctly. Be careful on the calculator. It is possible to make mistakes. And you don't need to write all the 0 substitute here, because we know 0 times anything, all these terms are all 0, so it's just going to be minus 0. And then you can use your calculator to show that should equal that. So Matthew, well done. That's the key to getting k equals 4, remembering gradient function, let dy dx equals 0. And we're way over an hour now, probably hour 15, and that's all we got time for. But like I said, these sessions will resume after Christmas. Only reason I'm not doing it next Wednesday is I have a Christmas dinner next Wednesday, so I cannot do the session. And I believe you all deserve a break the following week anyway, last week of the Christmas term. So you can have a bit of a holiday and a break there. Right, any questions? Normally I will get a bit more interaction, but because you've got your mocks tomorrow, I just try to cover quite a few skills that you can pick up some marks and skills that you might have forgotten. And next time we can do more complex, more difficult questions to move, you know, your grade Bs to an A or your grade Cs to a B, or etc.